Hi, we're doing some problems here. This is 182, Math 182. We're doing from 9, 10, numbers 8 and 9, which corresponds to numbers 47, and I think it's 63 in the book. Yeah. So these are the online problems. It says, find the first four non-zero terms of the Maclaurin series with the function by multiplying or dividing the appropriate power series. Use the table of power series for elementary functions, and it's f of x equals e to the x sine x. So in this, we first look at e to the x, and what that's going to look like. That's going to be 1 plus x squared over 2, or 2 factorial, which is 2, plus x cubed over 3 factorial, which is, oh, that looks horrible. That's 6, of course, so 3 factorial, plus x to the 4th over 4 factorial, plus dot dot dot, and just to restate that, it's 1 plus x squared over 2 plus x cubed over 3 factorial is 3 times 2 times 1, so it's 6, plus x to the 4th over 4 factorial is 4 times 3 times 2 times 1, which is going to be 24. Plus dot dot dot. For the sine of x equals x minus x cubed over 6 plus x to the 5th over 120 minus dot 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 dot. And it's really, it's x. It's going to be x cubed over 3 factorial. It's x to the 5th over 5 factorial. 5 factorial is 120. So we're multiplying these together. And we have 1 plus x squared over 2 plus x cubed over 6 plus x to the 4th over 24 plus, and then that's the part for e to the x. And we'll do the sine part, x minus x cubed over 6 plus x to the 5th over 120 minus, and we could go more terms, but we're just looking for the first 4 terms. And we multiply this out. I have 1 times x is x, 1 times, let's do this, x times x is x squared. So do the x there. And I'm trying to look where to multiply next. What if we did the x squared over 2 times x? That's going to be x cubed over 2. And then if I went, I'm looking at powers here. 1 times the negative x cubed over 6, that's going to be minus x cubed over 6. And so now I think that's going to exhaust the x cubes. Now let's look at x cubed over 6 times x is x to the 4th over 6. So I'm multiplying x cubed over 6 times x. Then if I did x cubed over, I think there's one more way to get an x to the 4th. Oh, right there. X to the 4th over 24. No, that's going to be there. Oh, there we go. X times x cubed over 6. So it's going to be minus x times x cubed is x to the 4th over 6. So I have my x squared, x cubed. If you notice the x to the 4th, that's going to go away because it just subtracts out. So we're going to have to go to an x to the 5th. Because we need the first 4 terms, non-zero terms. Now we can do 1 times x to the 5th over 120, so plus x to the 5th over 120. We can also get the x to the 5th by doing x squared over 2 times x cubed over 6. So that's going to make it minus x to the 5th over 12. We can also get it by doing the x to the 4th over 24 times the x, and that's going to give us plus x to the 5th over 24 plus dot dot dot. So if we simplify this, we have x plus x squared plus, and the common denominator for the x cubed over 2 minus x cubed over 6 is 3. So it's 3x cubed over 6 minus x cubed over 6 plus, and these go away, the x to the fourths are just going to go away. And then we have x to the fifth over 120 minus, and so the common denominator here is going to be 120. That's going to be 10x to the fifth over 120. And then multiplying by 24 by 5, we're going to have plus 5x to the fifth over 120. Okay. So we have x plus x squared plus 2x cubed over 6 plus, now we have an x to the fifth minus 10x to the fifth is a 9x to the fifth. Negative 9x to the fifth plus 5x to the fifth is going to be negative 4x to the fifth over 120. So we can reduce this a little, looks like a 7 there. We can reduce this a little bit. It's going to be x plus x squared plus x cubed over 6 minus x to the fifth over 30 plus dot dot dot. And those are the first four terms of their product. And then if we're going to look at the graph, it's going to be a quartic, being the fifth power, and leading coefficient's -1. So we have our choices on this graph. It's going to start high and end low, so it's not going to be the two on the right. It's going to have to be either the first or the second one. And let's see here. Put up my handy dandy calculator. Can't see this. Plus x squared plus x cubed divided by 6 minus x to the fifth divided by 30. Okay. And my graph comes out to be, comes down like this, goes up, drops like that. That's the first graph. Okay, so that's our first one. Let's look at number 10 now. Okay, for the next one, we're going to use the power series to approximate the value of the integral with an error of less than 0.0001. And they want us to round our answer there to 4 decimal places. So it's going to be the integral from 0 to 1 of e to the negative x to the 6th dx. And I just want to point something out, that e to the x is equivalent to the sum, or the series representation is going to be the sum as n goes from 0 to infinity of x to the n over n factorial. So when we have an e to the negative x to the 6th, that's going to be the sum as n goes from 0 to infinity of negative x to the 6th gets raised to the n power over n factorial. So what we have then is that our integral from 0 to 1 of e to the negative x to the 6th dx will become the integral from 0 to 1 of the summation as n goes from 0 to infinity of negative x to the 6th to the n over n factorial dx. We can re-represent it like that. Gosh, this writing looks so bad. Okay. And we can play with this a little bit. That becomes integral from 0 to 6 of, 0 to 1 of the sum as n goes from 0 to infinity of, and I could break this out. I have a negative 1 there to the n, essentially, so negative 1 to the n x to the 6n over n factorial dx. Now I can integrate and essentially integrate inside with that sum still there, and we would have the sum as n goes from 0 to infinity. That negative 1 to the n is not going to change. But this becomes x to the 6n plus 1. And of course, when you raise it to a power, power goes up by 1, you divide by that new power. 6n plus 1 times the n factorial. And we're going to evaluate this from 0 to 1 for x. And it goes from 0 to infinity of what? Negative 1 to the n, 1 to the 6n plus 1 over 6n plus 1 times n factorial minus the sum as n goes from 0 to infinity of negative 1 to the n, 0 to the 6n plus 1 over 6n plus 1 times n factorial. And so that second part just becomes 0. So we have the sum as n goes from 0 to infinity, negative 1 to the n times 1, because you can just drop that then, 1 to the 6n plus 1 is just 1, over 6n plus 1 times n factorial. And so this is going to be what? Let's start plugging numbers in. Put 0 in there for n, you're going to have 1 over 6 times 0 is 0 plus 1. It's 1. 0 factorial is 1, so 1 over 1. Minus now, because if you put n being 1, you get negative 1 to the 1, so negative from that. 1 over 6 times 1 is 7. Sorry, 6 times 1 is 6 plus 1 is 7. And n factorial, 1 factorial is 1, so 1 over 7. Put 2 in there for n. Negative 1 to the 2 is going to be 1. 6 times 2 is 12 plus 1 is 13. 2 factorial is 2, so it's 26. And put a 3 in there. Oops, it jumped up on me. Negative 1 to the 3 is negative 1, so minus 1 over 6 times 3, 18 plus 1 is 19. 19 times 3 factorial, 6, so 19 times 6. It's 120 minus 6. Oh, I think 114. I should have been able to do that in my head. 114 plus dot 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 plus 1 over, should I say, negative 1 to the n over 6n plus 1 times n factorial. Okay. So we need to figure out how many terms we need to go. I mean, this is, we have n equals 0, n equals 1, n equals 2, n equals 3. And we need to get to a term that adding that term is going to be less than 0.001. So we just got to start listing it out. So if we do n equals 4, n equals 5, n equals 6, n equals 7, let's see where this goes. So for 4, we're going to have 1 over 6 times 4 minus 1 times 4 factorial, which is what? Oh, it's 6 times 4 plus 1. I get 1 over 600, and that's approximately 1 divided by 600 is approximately 0.00167. That's not small enough. So do 5. It's going to be 1 over 6 times 5 plus 1 times 5 factorial. Give myself more space. So 1 over 6 times 5 is 30, 31, 31 times 120. I get 3720. 1 divided by 3720 is going to be approximately 0.000268882. So we're getting close. So let's look at n equals 6. 1 over 6 times 6 plus 1 times 6 factorial. That's 1 over 37 times, I think it's 720. 26640. .0000375. So as long as we go out to n equals 5, we should be good. We don't need that 6th one because it's not going to change it. And the next subsequent terms are not going to change it much either. So we could then say that the integral from 0 to 1 of e to the negative x to the 6th dx is going to be the sum as in approximated by the sum n equals in 0 to 5 of negative 1 to the n over 6n plus 1 times n factorial. And that's going to be approximately we have 1 minus 1/7 plus 1/26 minus 1 over 114 plus 1 over 600 minus 1 over 3720. I get approximately 0.8882. If I go to 4 places, it's 23032. But there we go. I hope that helps.